I'm going to present using my mobile device, but as a matter of fact, you're all allowed and invited to use your mobile devices. So if you grab your mobile devices and then go to, either scan the QR code or go to mentai.com, then I think I lost my sound or is it still working? Yeah. Okay, so once again, if you grab your mobile devices, you can actively participate in today's session. And I'm on a tight schedule, so let's speed up a little bit. So you can either scan the QR code, or if you're standing too far away from the screen, you can just go to mentai.com and enter the code. The code is 48340903, and I see one person, two, maybe multiple people are, well, successfully joining already, so that's good to know. You've got a little bit more time to join, but meanwhile I'm already going to proceed because once again we only have limited amount of time. What I would like to know is your role in your organization. So you can once again use the emojis to indicate if you are a product owner or from the marketing team or maybe even CEO, or if you are here with a technical role like CTO, developer, or whatever technical role. Or maybe another role could apply today as well. So most of you are technical, luckily makes my presentation a bit easier to do today. Okay, I'm going to proceed once again, and I think I wanted to say you can still join, but I don't see such option. Is there anyone that wasn't able to join, but did want to join? Right, fair enough. My name is both my height as well as my name is 16% shorter than Erwin. My name is Erwin Hofman, or in English, Erwin Hofman, whatever you prefer. I'm a developer, still a developer today since 2001. Became a consultant over time. PageSpeed, obviously, PageSpeed related audits, and well, I'm also giving audits and training sessions. And today I'm going to be giving a talk. And I'm here as a CTO of RunVision, which is a PageSpeed monitoring solution. And I even became last year, I even became a Google developer expert, which basically means Google is acknowledging that what I'm saying is quite correct. PageSpeed related once again. All right, let's proceed to the next slide. This is how our whole team looks like. Some of them are even here. Caroline is standing over there. Roderick Jackson moved to the other talk, just like Jordi, for example. And well, once again, everyone over here as well. What to expect? I'm going to talk a little bit about IMP, which is a new cool web vital metric. But I'm especially going to dive into the time first byte caching and a little bit of the office, which you will see right here. Because, well, cool that it's fast on my device, but obviously it also needs to be fast on the devices of our users. And then different conditions will apply, both device conditions as well as internet speed, for example, etc. So there will be multiple reasons why it might feel like, whenever you're building on a web shop, why it might feel like it is fast on your device and your maybe office Wi-Fi. However, once a visitor starts visiting the website, maybe you will see a bounce rate for whatever reasons. But I'm just going to move on because once again, I only have a limited amount of time. The first metric I want to talk about is INP, Interaction to Next Page. This is a new responsiveness metric. It's not really a page speed metric, but more of a performance-related metric. So whenever I click on Add to Cart, how fast does the user see some form of feedback, visual feedback? Another way, describing it in another way, how long is some part of JavaScript running, which is maybe preventing the next frame, the next visual change from happening. There are different ways. Well, I talked about this during the Performance Now event last year as well, the pre-event I should say, because well, obviously all sites out there are using third parties, and they will slow down your website. But it's quite hard to say which ones are exactly impacting your performance. You could use obviously Lighthouse, but you want to have data from real users as well to actually make proper decisions instead of just trying to cut away all third parties. Because we all know that all websites out there will be using third parties.
Like Tweakwise.
Like Tweakwise, for example, we didn't see any, no real impact because of the performance solution, JavaScript solution of Tweakwise, by the way. So that's good news today. A recap of IP instruction to explain is it was replaced, well, it was replacing FID last month. It is, I'd like to believe, and I think so, it is the most technical metric of all current full Web Vitals metrics. So the other ones are large content and CLS, cumulative layout shift. And it exists of 3 phases. And you can use it in, well, you can track it in different ways, in your dev tools, in, well, using RUM solutions like RUM Vision. And what you want to use is a low API, which is also relatively new, very new as a matter of fact. And different ways to fix it, but it's a bit too much to explain how to fix it in just this session, because, well, I also want to talk about time first wise in the second part of this talk. Nevertheless, I do want to elaborate a little bit on the different phases of an IMP, which I hope is making things a bit more clear to understand what IMP really is. I already said that IMP is, well, replaced FID, first input delay, and that also was the bottleneck of the first input delay metric. It really was only tracking the interaction during the first, first interaction, and only the input delay part, while in real life, browsers are doing way more, unfortunately, but also obviously, I guess, is doing way more on the main thread of the browser than just, well, the input delay. If this does not make sense, I hope that the next part is going to make a bit more sense. This is based on real user data, by the way, which is basically showing us, okay, in real life, apparently, we do have 3 phases, and each phase is taking a bit of time. So I'm now going to explain a little bit of what each of these are. For example, input delay basically means, well, first of all, I should add, once again, you could use Lighthouse, but within Lighthouse, obviously, you get a whole list of third parties that you might want to solve, but it is also time consuming. And as a developer, well, we want to make an impact as soon as possible. We can only spend our time once. So we want to work on the things that are really going to move the performance needle. And that's what IMP is about as well. IMP really is about tracking interactions and delays during an actual interaction, not just during the whole page life cycle. I only care about the ones and want to fix the ones that are actively blocking the main thread during a user interaction. If you can improve that, then, well, add to cart will improve, bounce will improve, etc. So then, whenever I click, once again, let's use the add to cart example. If I'm trying to click on the add to cart button, maybe some JavaScript is still running, like Hotjar or a chat widget or whatever. And that's basically what input delay is. How fast could the browser come back to any event listeners that were coupled to my interaction? So once again, let's say I click on add to cart, I've got an event listener that is then actively adding something to the cart, some JavaScript that needs to be executed during the on-click event, during the on-click event. However, there could be, so once again, third party running on a main thread like Hotjar or whatever. So that means the browser cannot actively go to my event listener right away. It first has to spend some time on the, finishing whatever JavaScript is still running at that moment. That's what the input delay is about. Then the actual processing time of my event listener is going to happen. And then maybe, well, let's say I clicked on the hamburger menu, and obviously you expect the hamburger menu to pop up as soon as possible. So you've got an event, on-click event. That's going to add a class to my whole navigation div or whatever, navigation element. But that element still needs to be rendered as well, obviously, because you expect a visual change. So that's where the presentation comes from, the presentation. So IMP exists of 3 different phases. And once again, you can see in real life, this is RUM Vision data, that in fact, time is spent in multiple phases, which is, in cumulative speaking, you get a specific number, and that is your IMP value. It should be below 200 milliseconds. I think it's about maybe 60% that is actually passed. 60% of 18 billion domains that Google is tracking is actually passing 200 milliseconds threshold. All right. Once again, I explicitly want to talk about time plus byte, so I'm going to just move on, although this is a little recap of the different phases. So once again, input delay means there is still some other JavaScript running, which was not related to my click. I think my screen just went, or it's now syncing. I'm not sure if I need to do anything here. to pause automatically, or is it you?
Performance issues of performance. Yeah, it's the input delay.
All right. So then we have got the processing time, which is actually the JavaScript that I wrote and that I coupled to my event listener specifically, and then any presentation that needs to happen, well, yeah, that needs to happen on the main thread as well. And then there are a lot of nuances, but I don't have time to explain and elaborate on that. But the browser is single-threaded, so it can basically only do one thing at a time when it comes to either rendering work or JavaScript work. Luckily, it could still continue downloading resources, but when it comes to actively executing JavaScript or doing any rendering work, browsers are single-threaded, which is our biggest, well, I want to say bottleneck, but maybe challenge to overcome as developers, as platforms, etc. In our vision, we are already using the so-called LOAF API so that you don't need to, or so that less technical people don't need to track that themselves and opening up DevTools and being overwhelmed by all the options in DevTools. And what we get is specific data per specific hostname. Well, as a matter of fact, if I would click on a specific hostname, I even get to see the individual file names. So with the LOAF API, once again, relatively new, I think it's shipped in Chrome 124, which is, well, what most people might still be running on. You get to see the exact third parties, but also first party, maybe if you're using hydration or whatever, Alpine included as well. You will get to see the exact host names where JavaScript was running from that was actively blocking the main thread when a user tried to interact. Once again, and that's what you would want to care about, when users are interacting, you don't want the main thread to be blocked. So that's what we do already out of the box when using OneFish. Enough about IMP, because I really want to talk about time first byte. Obviously, we all know about time first byte already, I hope so. So I'm just going to dive right in, and also got some quiz questions over here, so be prepared. But first of all, this is often the situation. We've got our web shop, we've got an even website, we've got a lot of extensions or plugins or whatever you want to call them. We've got ads that will impact time first byte as well. Might be a spoiler, I'm not sure. And obviously we've got platform and hosting challenges too. So different roles in our overall time first byte challenge. My first question is the time first byte equal to server response time? So this is where you can grab your mobile devices, and I'm going to the next slide, and you should then be able, on your mobile devices at least, you should be able to enter whatever name you want to use, your own name, or if you expect it to come on top, or the name of your cat or dog or whatever. Pick a name, and then you can actively join these questions. All right, I see some people joining already. Is someone not able to join? Okay, so I need a bit more time.
Yeah, just that the quiz is not open to reload or I don't see any.
It says quiz
Reload. Join on my quiz. Oh, that's a shame. Okay.
Quiz is not open.
You need to activate it, it says.
There it is again. It seems to be.
Is this open or?
It was, but now it's.
Oh,
it's on.
Okay.
Yes.
That's
Okay.
off, it
You can now
says.
enter your name.
No.
Now we get the next slide.
Okay.
So,
Let's try again.
Quiz is not open.
on this page it's closed.
That's a shame. So let's see what happens. Join our quiz. Okay.
That's it.
Well, I'm just going to proceed and see what happens. I just click start quiz, so I'm not sure if you're now able to join. Still unable to join? Okay, that's quite a shame.
Yeah.
I'm going to proceed nevertheless, and let's see what happens over here. If it's not over, please wait for the terms to activate it. Okay, well, I'm not really sure if I can do it from my own device over here. But it seems like I can not apparently. Okay, well, I'm going to proceed nevertheless. You can also use thumbs up or thumbs down, maybe that's a better option, so you should see this slide on your mobile devices. And if you give a thumbs up or thumbs down, if you agree, well, do you think time first byte and circle response time is the same? If so, thumbs up. If you think it's not the same, well, thumbs down. And most people are already picking thumbs down. And that's actually true. And I already gave it away in the next slide over here. Over here we can see which part is included in the time first byte. So over here we can see the request start and response start. So this would basically be the server response time. But in real life, in reality, obviously there is way more going on before we actually receive the first byte. So it is, well, any redirect time, any, well, time from the browser to try to maybe fetch anything from the cache, DNS lookup time, and TCP handshake as well is all included in the time first byte. So in reality, time first byte is way more than just the server response time. Which is what we are seeing over here as well. Once again, a screenshot from Run Vision. And we can see, when looking at the waiting time, which includes redirect time, that actually some time is being spent, not all the time, but some time is being spent in any redirects. And I hope it makes sense if I tell you that, well, in Run Vision you can do some filtering. And if you would filter on unique page hits only, then you would get to see some DNS lookup time as well, because when I visit the website for the first time, obviously the DNS lookup has to happen as well, while TCP handshake is happening more often during my whole session. And this is the breakdown that you get to see, and this actually is the pure, you could say the pure server response time. So yeah, time first byte does include way more than just the server response time. I had another question about percentiles, which percentile is being used by Google, but I'm just going to skip this. However, for those that do not know what percentiles are, let alone 75th percentile, I want to elaborate on this a little bit, because Google is using the 75th percentile. If you are looking at a page insights result page, for example, or if you're looking at the Crux data or Google search result data, Google is using 75th percentile for all of them. Which basically means Google looks at the best experience within the 25% worst experiences. Well, why this number? Why would you want to look at the 75th percentile? Because you could look at the 50th percentile or the median, but obviously you want to deliver an optimal experience for more than half of your visitors, because it doesn't make sense if you only want to optimize for the 50% of your visitors. You obviously want more people to convert. So that's why Google picked the 75th percentile. You could also aim for the 80th percentile, 95th percentile, but that would be harder. Maybe not for Dutch web shops, but it would be harder for when launching a shop in Germany or even the South of America, South of Africa, for example. So your audience matters as well. Then, when talking about time first byte and maybe even caching, we could look at the 75th percentile. However, obviously, you don't want to be blindsided by just looking at one percentile. You still want to know what the experience is at other percentiles. If you would always look at the same percentile, you would not get to see, well, maybe when your cache hit ratio is starting to drop, for example. So when looking at this graph, the first thing that comes to mind, well, at least my mind is, apparently caching is working perfectly up to the 50th percentile, but as of the 55th percentile, the time first byte is regressing. So by looking at such chart, you're able to say, okay, our cache hit ratio is about 50%, and as of 50%, visitors are having a worse experience that we really want to address as well. Because once again, you want to optimize for more than half of your visitors. I hope so, at least. And this is a histogram chart, which is basically telling you, okay, luckily, a lot of people are still ending up in having an optimal experience, a good time first byte. However, we can still see some outliers that we want to address as well. Because, well, a time first byte of 2.7 seconds isn't optimal. I just had, I'm not sure if he's here, but I actually heard a story yesterday about a specific plugin that the shop had installed, where it was purging the cache every minute. Well, it's quite clear that that is hurting your cache hit ratio big time, and then as a result, your real user experience as well. So you want to prevent that from happening for starters, obviously. Nevertheless, even then, you might, well, still purge your cache every day, for example. And it's not just caching, well, it is often caching. But what we're seeing quite often, more often than we would like to, well, merchants would like to admit, for example, is that, so it fully lock itself, no, there we go, all right, is that people are blind for traffic coming from ads, either Google ads or Facebook ads, and they are forgetting about the caching rules related to their previous strings that comes with any ad traffic, for example. So that's something that you want to be aware of as well. And this is how Provision is showing you that kind of data. Once again, you might often be blindsided if you are only using synthetic tests or lighthouse tests, because you would not typically not end up testing with different previous strings as well. However, this is reality. People might come not just directly to your web shop or from Google Organic Search, but maybe also Google Ads, maybe campaigns, etc. And if I'm seeing this kind of data, it's at least quite clear to me that, and we are talking about time-first buy data, by the way, that Facebook Click ID was successfully added to their caching rules. However, whenever Facebook Click ID was mixed with maybe an email campaign coming up with the typical UTM parameters, then apparently the time-first byte is already a bit higher. And over here, we can, well, clearly see that they forgot to add a combination of Google Click ID and underscore GL to their caching rules, for example. So the time-first byte is then double as high as, well, the other ones, for example. And this is, well, typical on-site calculation, for example. So, yeah, you could be blind for this when you are not monitoring this kind of data. And as I said before, typically, obviously, caching is being purged, well, maybe at least once a day, because a lot of changes needs to be made, etc. Prices changing. But even then, there might be a friend here, which is the back-forward cache. You might think that a time-first byte of 0 milliseconds is not possible, but nowadays, well, already since a few years, it is possible thanks to back-forward cache. It is not a server-side related, well, you might want to do some server-side tweaks, but it is especially a front-end related caching mechanism. All right, let's elaborate on this a little bit more. It's already supported by Firefox since 2005, Safari 2009, and Chrome in 2020. So it's already here for a while. And it's basically related to whenever I click on the back-forward buttons on my mobile device or desktop, obviously. So whenever I click on the back-forward buttons, a real page it might be happening. However, browsers would attempt to fetch the page from the back-forward cache, from their own cache. And it's basically trying to create a snapshot when I'm leaving the page. So when I'm leaving a page, the browser is creating a snapshot for any scenario that I'm going back to that page. And it should then be able, hopefully, to present the exact page from the snapshot cache. However, when you are using cache control rules, specific cache control rules, or using the unloaded event handler, for example, or having still some fetch calls opened, then the browser is not able to add that page to the cache. So that's something that you, as a developer or platform, should prevent from happening. I know this is a bit debatable, well, it's not debatable, but controversial maybe, so do address me later on if you have more questions about this specifically. But in real life, a time-first byte, this is all time-first byte data, a time-first byte of 0 milliseconds is then in fact possible. So if you are able to make the browser eligible for adding pages to the back-forward cache, this is what will be happening. And then you've got a direct win of 649 milliseconds within your time to first byte. This basically means these were, in fact, attempts by a user to click on the back-forward button, but something prevented that page from being added to the cache, and these were successful back-forward applications where the browser was then able to add the page to it, and not only add, but also present the page from the back-forward cache. And we can see that overall, 60K pages compared to, well, we can already manually calculate this is more than 10%, especially if we would sum these two up. It's more than 10% that is coming from, well, I should say more than 10% of your users try to click, and they do click on the back-forward buttons, but in most cases, well, you can see here, in most cases the browser was not able to present it from the back-forward cache. So yeah, there are clear advantages because, well, once again, 50% is typically using the back-forward buttons. The browser will try to present a snapshot where the scrolling position is maintained, and even any executed JS does not need to be re-executed. So once again, it's a pure win if even the scrolling position is still the same as my previous picture, for example. With, as a result, not only time per swipe benefits, but also LCP, CLS, and IMP. Because once again, all JavaScript was executed already, and it's a snapshot. So as a result, no JavaScript needs to be re-executed. So that's also here not only time to swipe related win, but also performance win. So back forward cache is your, I would say, best place cache. And I think, well, it's already the end of my slides. Obviously, this is not really personal illustration from the office. Nevertheless, you cannot improve what you don't measure. So as I showed before in the screenshot over here, these are all specific dimensions that I'm looking at. But it also depends on which filters I apply to this data to maybe come up with and see and spot other challenges. So yeah, once again, you can't improve what you don't measure. All right. I have one more question, but yeah, questions aren't working here. So then this is my last slide.